Alright, my name is Javier Serra. Today I'll be talking about the free body diagram analysis and the motor characterization for this project. Essentially what you want to do is that you're going to create your force equations in the x and the y, and I would recommend that you also work some moment equations into there, because you'll realize that the position of the center of mass in your car really affects how well your car performs, which you'll later find out as you do these free body diagram analysis. Essentially, you get a bunch of equations. I would also recommend that you make a MATLAB script and kind of plug these equations in just to kind of speed up the process, kind of change parameters around, see how that affects it. Because then effectively you'll be able to, there's a couple of parameters that you can kind of change, such as the wheel radius and the center of mass location and all these other parameters. And then from that, you'll be able to decide what is the best gear ratio you should choose. You'll want to basically plot RPM versus torque versus RPM, where torque is in the x-axis. This is done by characterizing your motor. You could easily doing this just by looking up like how to characterize motors on YouTube, and you'll find a bunch of videos. Essentially, you'll create these graphs and you'll realize, all right, I want to go as fast as possible, but I also need to produce this amount of torque according to the equations you solved. And then from there, you'll choose your gear ratio. Also, you have to take into account that you'll also be going up an incline, so that's another thing you can choose, because there might be different gear ratios that satisfy your torque requirement, but some gear ratios may be faster than others.
Go Birds.
Go Birds.
Hi, I'm Aaron Bowder, and I'll talk about some of the design choices that we made that are based on the science that Javi just talked about. So one of the main things that we discussed at first was having a larger wheel radius so that we could generate more torque while still having the optimum RPM. However, when we implemented this, our wheels were so large that they couldn't really fit inside of the tube without contacting the walls in some way that we didn't want. So we wound up going with a smaller wheel design of 2.5 inches diameter, and we have them a little farther spaced apart. And that's because when we implemented our last design, a major problem that we ran into was slipping up the sides of the tube. So our car didn't exactly run straight like we wanted it to. So we decided to go with this design. And another big design choice that we made was to go with one wheel in the back instead of two. And that was so that we could reduce the weight and have a faster car in general. However, when we implemented this, we found that the one wheel also affected how straight our car ran, and that it didn't run straight at all. So we decided to end up with this design where we have, similar to our first design, where we had one wheel in the back right here. This design we've got two, just so that it runs a little bit straighter and that we don't have to worry about balance or tipping or any of that. Another design choice that we made involved the placement of the battery. So initially we decided to have our battery on top of the motor, and we found that this placed too much of the center of mass too high, so we decided to put it in the back here so that it was lower to the surface of the tube. So those are basically the challenges that we ran into, and the main takeaways that we had. What do you think, Bobby?
You'll effectively learn how to basically create MATLAB programs that really allow you how to characterize the motor and kind of use that as a tool itself to decide what is best. For example, what Perrin and I did is that we kind of just wrote all of our equations into a MATLAB script, and then we're just like, all right, let's go with this radius. How does that affect our speed, our torque output, and all these other parameters? And that kind of gave us the best idea of what to choose.
Right.